Lesson 15.6 is about random variables and expected value. In a sports setting, there's often a variety of possible results which occur, and each one of those has its own probability. The individual probabilities for all of those possible results add up to 100%, but some are more likely to occur than others. For an example, we're going to look at a golf course where the first hole is a 350-yard long par 4. In case you're not familiar with golf, what that means is that the golf course expects that most golfers will be able to complete the hole and get the ball into the cup in 4 shots. So a par 4 means it should take you 4 shots. However, some golfers are able to complete the hole in fewer shots and some will take more. So we have a distribution that shows for a total of 2,225 golfers over the course of a year, what the number of shots each of those golfers took. So, what this table shows you, for instance, is that 4 golfers were able to complete the hole in only 2 shots, 150 golfers were able to complete it in 3 shots, 645 golfers took the 4 shots that they expected, and then all the way up to 49 golfers, which took 7 shots. Now, because the score on this hole is a result of a chance process, and because the score varies by golfer, we say that the score is a random variable, which in this case we're going to call X. Now, in some cases, for example, if you're rolling a die and you have 6 possible outcomes, we know that all of those outcomes are equally likely. But what happens more of the time is that you have some outcomes that are more likely to happen than others. And in this golf example, we can see that the most likely outcome is for a golfer to score 5, right? Because 992 of the golfers got a 5. Whereas very few of the golfers, only 4 out of the 2,225 that attempted that hole, were able to finish the hole in 2 shots. So the different values of the score are the different values of our random variable. And then we have the number of golfers or the frequency for each of those values. Now, typically what we want to do is we want to express these in terms of probability. So here we're going to fill in probabilities and we're going to make what's called a probability distribution. What this distribution shows is all of the possible values of our random variable X, which are all the possible scores on that hole, and the probability that a randomly selected golfer would get that score. So in the first box, for example, we know that 4 golfers out of the 2,225 golfers scored a 2. So 4 divided by 2225 gives us a probability of 0.0018. So that means if we randomly selected a golfer, that is the chance that they would finish the hole in only 2 strokes. 150 out of the 2,225 golfers finished in 3. So 150 out of 2225 is 0.0674. And then we can repeat that for the rest of the values of X in our table. For the next one, for example, we do 645 out of 2225. And we can repeat that and complete the rest of that table. Now, I'm going to 4 decimal places here, just for the sake of accuracy. And if I add those up and I fill in the total at the end, the total actually works out to be 0.9999. We know that because this represents the entire sample space, the total should be 1. And again, that's just due to round off error, which means that we rounded down more than we rounded up. And so our total was a little bit shy of what it should be. Now, based on this probability distribution, we can calculate what's called an overall expected value, and that represents the expected score on this hole. In other words, that would be if we randomly selected many, many golfers over a long period of time, and we took all of their scores on this particular hole and averaged them together, what would their average score be? To calculate this, what we would do is we would take each score and multiply it by its probability. So 2 times 0.0018 plus 3 times 0.0674. And we repeat that for all the values in the chart all the way down to 7 times 0.0220. And if we do that for the entire chart and we add those together, then the expected value of X is 4.7864. Now, how would we interpret this value? Because you can't golf the hole one time and get a score of 4.7864. In golf, you can only get whole number scores, just like basketball and basically any other sport. So, what this means is that if we were to randomly select golfers over and over again, or many, many times, golfers who played this particular hole on the Indian Springs course, their average score would be 4.7864 strokes. So, expected value represents a long run average. What would happen in the long run when many, many, many golfers play this course, or we randomly select a golfer over and over many, many times? Here's another example. We're going to suppose that X represents the number of points scored when a high school football team starts on their own 20-yard line. So you could have basically, in this case, it's very simplified, but three possibilities. Either they score 0 points, which means they're not able to get any points on their possession and they turn the ball over, or they could score a field goal by kicking 3 points, or they could score a touchdown and get the extra point following, which would give them 7 points. So we've got most of the chart filled in. The only thing that's missing is the probability in this box right here, right? That's what we need to find. And so we're going to do that, and then we're going to also answer the questions. So first, the shaded box there is the value of X is 3, and the probability that X is 3 is 0.13. What that means is that the probability that this team scores 3 points when they start on their own 20-yard line is 0.13. Now, to get the missing probability, we know that the total for these three outcomes should be 1. So if we add up the two probabilities that we know, the 0.62 and the 0.13, and then we subtract that from 1, that will give us that missing probability of 0.25. So we did that. Now we can do the expected value, and you have to have the chart complete before you can do that. So we take each score and we multiply it by the probability that it occurs. So 0 times 0.62, 3 times 0.13, 7 times 0.25. That gives us an expected value of 2.14. Now, again, it's impossible for the football team to score 2.14 points on any of their possessions. However, that represents a long run average. So how we would interpret that is we would say in many, many plays, the average number of points the team would score would be 2.14 points. Now we can write down a formula for expected value, and we'll do that now. You don't really need to know the formula as long as you understand the process for how to calculate expected value, but this is what the formula looks like. We use E of X to stand for the expected value. And to find the expected value, we take each value of the variable, which we'll call X, we multiply it by its probability, so that's P of X, and then we add all of those together for each value of X. So that's what the formula looks like in math symbols. All right, please complete the 15.6 homework in your assignment packet.